Welcome back to the channel. Today I will be discussing why Fusion 360 will sometimes not generate a toolpath for an inside loop. I wanted to cut a 0.01 inch ID hole and a 0.25 inch thick piece of mild steel. The kerf for my torch is 0.055 inch thick for this piece of steel, and I got that from the Hypertherm charts. Fusion 360 sets the pierce clearance to the kerf width by default, which is what I used. Fusion 360 also sets the lead-in distance to 0.19425 inch by default. It also sets the approach angle to 60 degrees, also by default. Unfortunately, Fusion 360 would not generate a toolpath to cut this hole with these parameters. I then set the approach angle to 90 degrees and kept reducing the lead-in length to find when Fusion 360 would finally generate a toolpath. It turns out that it will generate it when the lead-in is 0.1375 inches or less when the sweep angle is 90 degrees. So let's look at a diagram of this geometry. The first geometry depicts a sweep angle of 90 degrees. The second diagram depicts a sweep angle of 60 degrees. As you can see, the pierce kerf falls outside the inside loop that is to be cut, so Fusion 360 will not generate a toolpath. This applies for any inside loop that you want to cut. If you have declared your entry point in a narrow section of an inside loop, there is a good chance Fusion 360 will not generate a toolpath if the pierce kerf comes within 0.08 inches of the loop boundary. You can see the toolpath and the torch kerf outline in this diagram. From this diagram, we can derive the following equation when cutting a circle. The max lead-in must be less than or equal to the diameter of the hole minus the kerf width minus 0.008 inches. I had to add a 0.008 inch fudge factor to get it to agree with what Fusion 360 is actually doing. The 0.008 inch appears to be a safety buffer factor. From these results, I was able to codify the following procedure. If Fusion 360 will not generate a toolpath for an inside loop, you have several options. Number one, increase the sweep angle. Number two, decrease the lead-in length. And number three, select any entry point where the inside loop edges have the largest separation. For a circle, it does not matter. There are some performance implications with decreasing the lead-in below a certain length. You want the torch stabilized at its normal cutting parameters by the time it reaches the end of the lead-in. This implies there are limits to how short a lead-in can be. Let's look at another diagram. This is a depiction of what happens during an optimum pierce and lead-in. The torch goes to the pierce height, fires, and then waits for the pierce delay time to expire before moving. This delay is not intended to produce a through hole. The torch then moves at the set lead-in speed. This movement before burn-through occurs allows the molten slag a place to exit at the rear of the torch, often leaving a rooster tail of slag on the surface. At the end of the lead-in, the torch should have transitioned to the normal cut speed and cut height setting. This results in a ramp cut from the center of the pierce hole to somewhere along the lead-in. If the lead-in is too short, the cut may not be stabilized by the time it reaches the end of the lead-in, resulting in an initial poor cut. If you are forced to use a short lead-in, then you should consider using a slower lead-in speed to allow the cut to stabilize before reaching the end of the lead-in. Hope this helps. Thanks for watching.